Problem number 12. Let's say we want to find critical points of f of x, y, z is x squared y z to the fourth on the unit sphere, x squared plus y squared plus z squared is equal to 1 using Lagrange multipliers. So the way that we're going to think about this is the thing we're trying to maximize or minimize. We aren't actually going to maximize or minimize in this problem. We could if we wanted to, but this is the thing that we're trying to maximize or minimize. And this right here is our g of x, y, and z. Okay, what's the system of equations we must solve? Well, that's going to be gradient of f is equal to lambda times the gradient of g plus also we'll have the g of x, y, z is equal to 1. So to write this out explicitly, what's the gradient of f? The x partial derivative here is 2x y z to the fourth. The y partial derivative is x squared z to the fourth. The z partial derivative is 4x squared y z cubed. And we want this to equal lambda times the gradient here of g. The x partial derivative is 2x. Then the other two partial derivatives are 2y and 2z. So what is our resulting system of equations here? So 2x y z to the fourth is equal to lambda times 2x. X squared z to the fourth is equal to lambda times 2y. And 4x squared y z cubed is equal to lambda times 2z. And don't forget, x squared plus y squared plus z squared is equal to 1 from up here. Okay, so what is this going to give us? Let's see here. So let's divide. Let us see how we can attack this. We need to solve this system of equations. I'm going to divide the first equation by x, the second one by y, the third one by z, just so that we can have lambda equal to, well, you know what? Let me do a common little trick here. What I'm going to do is that I'm going to multiply. Instead of dividing, I'm going to multiply instead. I want to make the right side of these all the same thing. How do I do that? I multiply the first equation by yz, the second one by xz, the third one by x times y. And so this is going to give us the resulting set of equations. So multiplying this equation by yz gives us 2x y squared z to the fifth is equal to 2 lambda xyz. The second one will be multiplying this one by xz will give us x cubed z to the fifth is equal to 2 lambda xyz. The third one, multiplying it by x times y, will give us 4x cubed y squared z cubed is equal to 2 lambda xyz. And so this is enough to show us, this is enough to convince us that 2x y squared z to the fifth needs to equal x cubed z to the fifth needs to equal 4x cubed y squared z cubed. Because all of these are equal to the same quantity, so they all have to equal to each other. Okay, so this is where we're at right now. Don't forget, we still have x squared plus y squared plus z squared is equal to 1 hanging around for us to use. What progress can we make here? So by the way, let's just be clear here. We are done with part A of the problem. Part A says, what's the system of equations you must solve? Basically just writing down this much stuff right here. We're done with part A of the problem. So now it says find the critical point whose coordinates are all positive. So to do that, this is going to be nice because we're assuming all the coordinates are positive. That means that they're not 0. That means that we can divide like by x, by y, by z if that helps make our lives easier. And so something that we're going to do right now is I want to divide all parts of this by xz cubed. Every equation in here, every term here has at least a factor of x and a factor of z cubed in it. And so this leaves us right now with 2y squared z squared is equal to x squared z squared is equal to 4x x squared y squared. Okay. Now, let's try to write z and y in terms of x. So looking at, let's say, this equation here. Let's see. Nope, that's going to allow me to... Oh, well, this might not be the way I intended to do it, but we'll just try it and see what progress we can make. X squared z squared is equal to 4x squared y squared. Divide both sides by x squared. Z squared is equal to 4y squared. So that gives us information about z and y. How they relate to each other. Looking at these two, divide out by z squared here. X squared is equal to 2y squared. Okay, and so what this is doing here is that, hey, look at this. We just wrote x squared in terms of y. We wrote z squared in terms of y. And so this allows us to substitute in 2x squared plus y squared plus z squared is equal to 1. 2y squared plus y squared plus 4y squared. I replace x squared with 2y squared from this equation. I replace z squared with 4y squared from this equation. This needs to equal 1. 2 plus 1 plus 4 is 7y squared is equal to 1. So that allows us to conclude that y squared is equal to 1/7. So y is equal to plus or minus square root of 1/7. Okay, so this is the y coordinates. The x coordinates, and we're told that x squared is equal to 2 times y squared. X squared is equal to 2 times 1/7. So x is equal to plus or minus the square root of 2/7. And z is 4 times y squared. So z is 4 over 7. So sorry, z squared is 4 over 7. So z is plus or minus square root of 4 over 7. So there's actually going to be 8 critical points in total. X can be plus or minus square root 2 over 7. Y can be plus or minus 1 over square root of 1 over 7. Z can be plus or minus square root of 4 over 7. But we only care about the one, we're only asked for the one where the coordinates are all positive. So that's going to be square root of 2 over 7, square root 1 over 7, square root 4 over 7. So that's how we find this critical point.